Welcome back to the Simulator series. In today's episode, we're going to be creating a loading screen for when players first join our game. Now, hopping directly into Studio, the first thing that we're going to do is start off by creating the GUI. So, inside of the Starter GUI, we're going to go ahead and create a brand new screen GUI, and we're going to rename this to be called Loading. We're going to want to make sure that we set Ignore GUI Inset to True, set Reset On Spawn to False, and then for the display order, we're going to set this to something like 9,999. And the reason for that is because we want this GUI to appear over top of every single other GUI that's in our game. We talked more in depth about the display order property in the last episode, so if you're completely unfamiliar with this property, I'd recommend either reading up about it or watching basically the intro of the last video where I went over this topic as well. By default, the display order is set to 0 for every single screen GUI, and in the last episode, I think might have been the first time we actually modified the display order property of a screen GUI, and we set that to 1. So realistically, we could set the loading screen GUI display order to 2, but we never know in the future if we might add a new screen GUI and we need that display order to for some reason be higher than notifications, but we also want that to be below loading. So that's why we're setting loading to an extremely high number, because we know that the loading GUI should always appear over top of every single other GUI. Anyways, with all that being said, let's get into actually constructing the GUI. Now, rather than adding a frame to this, we're actually going to go ahead and create a canvas group. This is something that Roblox added in recently, but basically you can think of a canvas group as similar to a frame. So we can see that when we added this to the GUI, we got a small white square as we would with a frame. And now why we're using a canvas group over a frame is because the canvas group allows us to modify one of its properties, and then that'll modify all of the descendants inside of it as well. So to demonstrate this, I'm just going to grab the frame from the Rebirth shop and put that inside of our canvas group. I'm also going to make this a little bit larger just so that we can see this better. And now let's look at the frame. When I set the background transparency property of the frame to 1, that only adjusts the frame's background transparency, but the background transparency for everything inside of it still remains exactly the same. Now let's go ahead and undo that. This time we'll look at the canvas group, and inside of here we can see that we have a background transparency and a group transparency. Now if we set the canvas group's group transparency to 1 without actually updating the properties of all the descendants inside of it, like for instance, if we select the frame again, we can still see that the background transparency is set to 0 here. It's not like the property was actually changed to 1, but instead the canvas group has an effect on all the descendants inside of it that pretty much applied this property's modifications without actually updating all of their properties as well. So of course, if we set this group transparency to something like 0.5, that affects everything inside of the group as well. Now, how we're actually going to use this canvas group is once the player has actually loaded into our game and we want to stop displaying the loading screen to them, rather than having to update individual properties of every single descendant that's inside of this GUI, we can simply modify the group transparency of the canvas group, which will have an effect on every single descendant inside of it. So it basically saves us a lot of work. Now, I just undid everything that you just saw, as that was only to demonstrate the usefulness of a canvas group and sort of how we're going to be using it. But anyways, going back to the canvas group, what we're now going to do is set the size of this to be the entire width and height of our screen. So 1 on both the X and the Y scale. And now next what we're going to do is add a frame inside of here as well. And we're going to set the size the exact same. So 1 on both the X and the Y scale. Now, with inside of this frame, we're going to go ahead and create a UI gradient. We can then select the UI gradient, click on the color, and then click the 3 dots to the right of it, and now we can modify this gradient a little bit. Let's go ahead and click this yellow arrow on the left right here, then we'll select the color, and for the color of this, we're going to go with a lighter blue. Now that we've set that color, let's select this arrow towards the right, and then click color once again. And then for this color, we're going to go with a slightly darker blue. And now I'm only going to set 2 colors for a gradient and close out of that. Next, what I'm going to do is alter the rotation of this, and I'm actually going to set the rotation to 90, so we have the lighter blue starting at the top, the darker blue starting towards the bottom, and then they both collide in the middle. And now we're done with creating the UI gradient. So once again, we're going to go inside of the frame, and this time we're going to create a text label, and of course, we're going to rename that to be called title. Now, for the text of this text label, we're going to say something like clicking simulator, as that's the name of our game. We'll set the text to scaled, and we'll also actually set the text to white as well. Along with that, let's of course set the background transparency to 1 so that we can see how our text is looking. Then let's go ahead and update the font. We'll set that to Gotham SSM, and we'll also make this bold as well. And we could even make the weight something like black, because this is going to be some pretty big text. Now let's go ahead and resize as well as reposition it. Now for the size, I'm going to go with about 0.45 on the X and 0.15 on the Y scale. Of course, when it comes to the position, for the anchor point, we're going to set the X to 0.5, and we'll set the X scale of the position to 0.5 as well, because we want to center this horizontally, and then we're going to want to drag it down a little bit as well. Now inside of this title text label, we're going to go ahead and add in a stroke. We'll then set the thickness to about 10. And for the line join mode, personally, I like bevel. And the reason that I choose bevel is because if you look at the letters which have circles inside of them, sort of like this O or G right there, and by default, that's set to round, I don't really like how the stroke appears there and kind of leaves another circle inside of it. I'm just personally not a fan of how that looks, so that's why I prefer bevel, because it leaves no circles and basically fills the entire thing. which I think looks better than round, but of course everybody has their own preferences. And I'm certainly no designer or creative, so your choice is probably better than mine. Anyways, the next thing that we want to do is add in a progress bar to this. Now, rather than recreating the entire progress bar, let's just go ahead and find one of our previous ones, and we'll go ahead and grab the progress bar from our achievements GUI. So let's go ahead and copy that, and then we can paste that directly into the frame by hitting Control, Shift, and V. Cool, there we go. Now that is quite large. Of course, we're going to want to resize it. On the X, I'm going to set that to 0.5, and on the Y, I'm going to set that to about 0.1. We're then also going to want to center this as well, so let's set the anchor point to 0.5, as well as both the X and the Y scale. Awesome. Now that we've done that, let's go ahead and actually update the background color of the progress bar frame, and we're actually going to set that to a white. Then, inside of the progress bar frame, let's go ahead and actually delete the amount text label. Then let's select the progress frame inside of here, and we'll also update the background color of this, and I'm going to set that to a lighter green. Awesome. Now that we've done this, I'm going to duplicate this UI stroke from inside of the title text label and put that inside of the progress bar. Now, for this UI stroke, since we do have UI corners inside of here, we're intending for the corners of this frame to be a little bit more round, so let's alter the line join mode from bevel back to round, as that looks significantly better. Then we'll go ahead and duplicate the title text label, drag it above the progress bar a little bit, and we'll rename this to be called loading. Then for the text of this, we're going to say something like loading ... We also definitely want to resize this a little bit as well. So now on the X scale, I'm going to set that to 0.375, and on the Y scale, we're going to go with 0.1. We'll then drag this down a little bit further, as I want this just to be a little bit above our progress bar. Along with that, we're also going to update the thickness of the UI stroke inside of here as well. Because we made this text a little bit smaller, I want to decrease the thickness as well, and I'm going to set the thickness to about 8. And now, with all that being said, we're officially done with creating this GUI. So now, what we're going to do next is we're going to leave this GUI to be enabled, but rather than leaving this inside of the player's starter GUI, we actually want to drag this all the way up and put this inside of Replicated first. And now we no longer see the screen GUI. The reason that we're storing this screen GUI inside of Replicated first is because anything that's inside of Replicated first is going to be prioritized to be replicated to the client before anything else. Now, to give you a TLDR about replication, whenever a player joins our game, Roblox needs to send all of the data that's inside of our game to that player. And what I mean by data is everything that's inside of the workspace, but of course this depends if you have streaming enabled or not. Sometimes it won't send everything and it'll only send what the client needs exactly right then. It also needs to send everything inside of the starter GUI to the player, the starter pack, the starter player, and other things like that. If Roblox didn't send this information to the client when they joined our game, then the client wouldn't really have any idea of what the game is made up of, so they really wouldn't be able to see or do anything inside of that. Now, going back to Replicated first, whatever we put inside of here will have a much higher priority to be replicated directly to the client before other things are. Let's say that we were to store this inside of the replicated storage, then in a way, this GUI has a chance of being sent to the player after, say, everything inside of the workspace has been loaded, everything inside of the starter pack, the starter player, and everything else like that. So that's why we're putting this inside of the replicated first, because we want to tell Roblox, prioritize sending this to the player first as soon as they join the game before you replicate anything else. Now, along with putting the screen GUI inside of the replicated first, we also have to create a local script inside of here as well. We'll go ahead and rename this local script to be called intro, and then we can start creating some variables inside of here as well. Now, similar to pretty much every GUI script that we have created, we're going to want to get some services, such as the player service, the replicated first, the replicated storage, the tween service, and then we're also going to want to create some variables for the player as well as the player GUI. Now, you might be thinking, well, if we use wait for child inside of here, will that kind of make the script run after everything else has been sent and effectively making the intro screen useless? Personally, that's something that I definitely considered when first working with Replicated first, but that's not something that you actually have to worry about. No matter what, the player GUI does need to be loaded because we need to store our GUI that we want to display to the player inside of the player GUI, otherwise they won't actually see it. Like, remember, when we put this loading GUI inside of the Replicated first, we no longer actually saw the GUI because it's no longer inside of starter GUI, which is where we store GUIs at inside of while we work on them inside of Studio in order for us to be able to see them inside of Studio. So anyways, going back to creating all those variables, we then want to create a variable for the GUI. So we're going to say replicated first dot loading. And we want to create some variables for the canvas group as well as the frame. So GUI.canvas group and canvas group.frame. We'll then also create two more variables. The first one's going to be for the loading text label, and the second one is going to be for the progress bar frame. Now, the next thing we want to do is actually create a variable called state manager, but we're not going to set this equal to anything. And the reason that we're creating this variable is because one aspect of creating this loading screen is to prevent players from seeing most of the GUIs, such as the currency GUI and everything else like that, which by default has sort of placeholder values and not the actual amount of currency that the player realistically has, because they're waiting on that data to be loaded and replicated from the server down to the client. So now, the next thing that we're going to do is say task.spawn. We'll then create an anonymous function inside of here. And inside of here, we're actually going to set the state manager variable. And how we're going to set this variable variable is pretty much as we normally would. We want to go ahead and get the state module script, which is inside of the replicated storage. So we're going to say require, then we'll say replicated storage. But rather than dot indexing, we actually need to use wait for child, because remember, we're creating this inside of replicated first. And since we're creating this inside of replicated first, that means that the replicated storage probably has not been replicated to the client before replicated first was, because that would not exactly make any sense. So first off, we have to wait for the client folder to be replicated, and then after the client folder has been replicated, we also have to wait for the state module script to be replicated to the client as well. And now as you see, we're using two wait for child statements inside of here, so that's why we're using task.spawn, because we don't want to stop the script right here while we wait for the state manager to be actually loaded. Now next what we're going to do is create another function which is going to be called loading loop, and that's not going to have any parameters. Inside of here, we're going to create a variable called loading text, and we're going to set that equal to loading. We'll then create another variable which is going to be called loading progress, and we're going to set that equal to math.random, and we want to generate a number between 1 and 10. And now once we generate that number, we also want to divide it by 100. The reason that we're doing this is because we're going to use this variable to set the X scale size of the progress bar's progress, and we're generating a number between 1 and 10 because I feel like we don't always want the progress bar to actually start at 0. I think rather than starting at 0%, we should start somewhere between 1 to 10% just to make it feel a little bit more natural. Now, after we've created those two variables, we're again going to use task.spawn and create an anonymous function inside of here. Then what we're going to do is actually set the progress size. So we're going to say progressbar.progress.size equals, and we'll use a udim2.fromScale. And for the X, we're going to use loading progress. And for the Y, we're going to use 1. So now we've just set the initial progress of the progress bar for as soon as the player joins our game. Then we'll use task.wait 0.1 to just wait a tiny bit. And now we're going to create a while loop. So we're going to say while, and we want this while loop to run if the game has not been loaded and if the state manager has not finished getting all of the data yet. So we're going to say while not, and then we're going to use the game data model. And this actually has a property inside of it called isLoaded, which returns true if the client has finished loading the game for the first time. So that's how we can check if the game is loaded, which should include basically all the models and anything inside of the workspace or other services that needs to be loaded for the player. Now, along with that, we're going to say or, and we also want to check if the state manager has not been loaded either. So if either of these are not loaded, then we want to continue going through this loop. So now inside of here, we're going to create a variable called isDataLoaded, and that's going to be equal to the state manager not equaling nil. Now, the progress of this progress bar is going to be entirely artificial. There's not really an actual way of tracking what percent of the game has been loaded for the player. So this is going to pretty much be entirely fake, but the player most likely doesn't know that. And even if they did, I don't really think it matters, as I think this loading screen is better than them just loading directly into the game, then having GUIs which look odd and don't actually reflect the data that they've seen previously, and then of course waiting for those to be updated. So I think this looks a whole lot smoother. Anyways, with that being said, the next thing that we're going to do is create a variable called max increase. Now, with each iteration of this loop, we basically want to increase the progress very slightly. But another thing that we want to take into consideration is if the loading is taking a longer time than it normally would, then we want to decrease the amount of progress that we're adding to the bar with each iteration. So we're going to say if loading progress is greater than or equal to 70, then the max that the progress bar can be increased by is going to be 1. Otherwise, the max that it can be increased by is 3. So now let's go ahead and set the loading progress variable once again. Now first we're going to say math.min. And the reason that we're saying math.min is because we don't want the progress to go above a specific number, such as something like 90. We really don't want the bar to reach 100% before the player's data has actually finished loading. Otherwise, that would mean our progress bar makes literally no sense, and it would probably completely ruin the immersion for the player. So we're going to say math.min, and now to actually generate a number, what we're going to do is use loading progress, and then we're going to add math.random to this, and we're going to generate a number between 1 and max increase. So of course, depending on the amount of progress that the loading bar is already at, the number that can be generated is going to be between 1 and 1 or 1 and 3. So now after we calculate our new loading progress, we of course want to divide that number by 100. Because we're using scale, if we set that to 22, then that'll be significantly larger than we're actually intending for it to be. We would want to set that to 0.22, which would be 22% out of 100. And now remember, we're using math.min, so this is going to be the first argument to that. And now for the second argument of math.min, we're going to pass through 85 because we don't want the loading progress to go higher than 85. And now that we've set the progress, let's go ahead and actually update the progress of the progress bar. So we're going to say progressbar.progress, and then we're actually going to use a method on this called tweenSize. And now we want to specify the end size. So we're going to say udim2.fromScale, and we can use loading progress as well as 1 for the Y scale. For the next argument of the tweenSize, we need to specify the easing direction. So we're going to say enum.easingDirection. Now we need to specify the easing style. So enum.easingStyle.linear. And we also need to specify the duration as well. file, which we're just going to set to 1. So now that we actually tween the size of the progress frame, the next thing that we want to do is check how long it's been since the player has began loading in. And the reason that we're doing that is because if the player is taking longer than normal to load into our game, we want to inform them of that. There's definitely a chance that their device might be really bad, maybe their internet's really slow, or Roblox could even be having some issues in their servers as well. Now, in order to determine how long the player has been loading into our game for, we need to create a variable outside of this function. So we'll create a variable above state manager, which is going to be called start time, and that's going to be equal to os.time. And of course, that variable is going to be set as soon as this script is loaded. So now, going back inside of our while loop, we're going to create a variable called seconds since start, and that's going to be equal to os.time, and we're going to subtract the start time from the current time. Then we'll create a variable called is taking long time. Now, what I feel like equates to a long loading time, it of course really actually depends on your game. If you have a ton of assets inside of your game, then it might take a lot longer for the player to actually load all of those in. Personally, I would say anything longer than 10 seconds is more on the longer side, but of course you can modify this to fit your own game as well. So this variable is going to be set to true if seconds since start is greater than 10. So if we've already been loading for 10 seconds, then I think we're taking a long time. Now, if the player is taking a prolonged time to actually load into our game, we want to inform them of this by updating the loading text label. So we're going to say if not is data loaded and is taking long time, then we're going to set the loading text variable equal to loading your data is taking longer than usual. And now that we've set that variable, let's go ahead and actually update the text of the loading text label. So we'll set that equal to the loading text. Now we're also going to modify the loading text once again, because with each iteration, we want to actually add another period onto the end of the text. So here's just a quick example of what I mean by this. With the first iteration, we're going to say something like loading. With the second iteration, we're going to say loading dot. Then for the next iteration, we'll say loading dot dot, then we'll say loading dot dot dot, and once we reach 3 periods, we're going to reset the string back to simply loading, and then restart the loop of adding periods to the end of this once again. So to do this, we're going to say loading text equals, and then we'll say loading text dot dot, and then we'll add a period to the end of that string. Now that we've added the period to the end of the string, we need to check the amount of periods that we have added to that string total and see if we need to reset that back to no periods at all. So we're going to say if loading text, and then we're going to use the match method on this, and for the match method, we need to provide it a pattern. Now, most people would assume that by pattern, they just want a specific string that we want to actually look for. But you can kind of do some cool things with creating a pattern, and it's not an exact string that it's going to look for. In a way, the pattern has its own scripting language to easily look for very specific things, and it's really cool in that regard. But we want to use this method in a very simple and straightforward way, and we pretty much just want to see if the loading text has 4 periods at the end of it. Now, in order to do that, we need to prefix these periods with a % symbol. And now after that, we can type out 4 periods. So if the loading text does find 4 periods inside of the string, then what we want to do is remove all those periods inside of there. So we're going to say loading text equals, and now we're going to say loading text once again and actually use the gsub method on this. And once again, we need to provide gsub with a pattern similar to how we did match. Now remember, like I said, to specify to the pattern to look for a period, we need to prefix that with a % symbol. So we're going to say % and then period. And now what do we want to replace it with? Well, we just want to replace it with a blank string. So using this gsub method, we'll replace every single period inside of loading text with a blank string, effectively removing all those periods and just leaving all of the other text. And now that we're at the end of the loop, we're going to say task.wait, and we'll wait half a second. Now, another thing that we actually need to account for is when we set the loading text to our new string right here, because the player is taking a while to load. And what we need to account for here is if the loading text is already equal to this string, then we don't want to reset it back to this string, which would effectively automatically remove all the periods that are at the end of it already. So what we need to do is before this if statement, create a new variable, which is going to be called isLongLoadingTextSet, and that's going to be equal to loading text. And this time we want to use the find method on that string. And now we want to actually check if this string exists inside of there. So we can go ahead and copy and paste that. So if we're able to find this text inside of this string, then we know that we don't want to reset it back to this specific string. Instead, we want to skip over this if statement and just continue to add periods to it, or maybe even reset its periods once it reaches down here. So of course, in order to skip over this, based on that, we have to go back to the if statement, and we're going to add another and inside of here. And now we only want to set this text if the isLoadingTextSet is not true. Awesome. And that's actually everything that we have to do inside of this while loop as we're waiting for the player's data to be loaded. We then want to go outside of the while loop. So everything that we write here is going to be what happens after the player's data has actually finished loading. Now that we know that the player's data is finished loading, let's go ahead and update the text of the loading text label. So we'll say loading.text equals equals, and we'll say loading finished, enjoy. Now, we also want to tween the progress bar as well to make that reach 100%. And rather than using tween size like we did previously, we're going to create a variable for the tween info and the tween, and do this tween, what I would say is more of the usual way. So we're going to create a variable called tween info, which is going to be equal to tween info.new. This is going to last 1 second. We'll use the same easing style, which is linear, and the same easing direction, which is out. We'll then create a variable called tween, which is going to be equal to tween service, create. The instance that we want to tween is the progress bar.progress. The tween info that we want to use is that variable right there. And now we need to create a table with the property that we want to update. So we'll say size, and we want to set that equal to udim2.fromScale, and we want to set both the x and y scale to 1. Now that we've created that tween, let's go ahead and actually play it. And then before we do anything else, we actually want to wait for it to be finished. So we'll say tween.completed and then wait, which is pretty much the equivalent of using task.wait and then specifying the amount of time that it would take for completed to actually be fired off. So now, after that tween has completely finished, the next thing that we want to do is actually tween the group transparency. So that'll kind of give a smooth transition of making the loading GUI just fade out and disappear. So we'll create another tween, but we're going to use the same tween info. So we'll just say tween equals tween service, create. We'll use the canvas group as the instance. We'll use tween info for the info. And now the property that we want to update of this instance is group transparency, and we want to set that equal to 1. We then want to go ahead and play that tween. And again, we want to wait for that to be completed. And finally, once the tween is completed, we're going to go ahead and actually destroy the GUI because we no longer need it. Awesome. And with all that being said, we're now done with creating this function. Now, there's just a few more things that we need to do. And the first thing we need to do is the replicated first service actually has a method called remove default loading screen. So we'll go ahead and call that to remove Roblox's default loading screen. We then need to make sure that we parent the loading GUI to the player's GUI so that they can actually see the GUI. So we'll say GUI.parent equals player GUI. And now after we make sure that the player can actually see the GUI, we'll go ahead and call loading loop so that the animation and everything else like that is actually activated. So one slight correction that we actually have to make is with how we set the loading progress variable. Remember, the whole reason that we're using math.min here is because we want to prevent the progress bar from reaching 100% before the player's data has actually been loaded. So what we're doing right here is we're basically limiting the progress bar to load up to 85% before stopping, or at least that's what we meant to do. Now the issue here is that we're supplying 85 as the second argument to math.min. And the issue with that is if we look at the first number that we're supplying to math.min, basically, this number is divided by 100. So let's say based on this calculation that the progress is like 10%. Rather than the number being 10, it's actually 0.1. So rather than saying 85 here, we actually want to say 0.85. Alternatively, you can also just divide 85 by 100, as that's pretty much what we're doing here as well. But it really doesn't matter which way you write it. They effectively do the exact same thing, so it just depends on how you feel like writing it. And now with that being said, that'll prevent the progress bar from going over 100%, and more specifically, going over 85% before the player's data has actually been loaded. Awesome, and now that we've done all that, let's go into our game and test this out. So now, once we start up our game, we can see that we first see a loading screen, we can see that the loading text and the progress bar is being updated, and then once we actually get our data, we see loading finished, and the GUI slowly fades out, eventually disappearing, and now we are into our game, and we can play it as we normally would. Of course, when you test this in studio, you're probably going to load in significantly faster than the average person would for a Roblox game. So if you want to kind of test out the longer loading text, I would go back to the is taking long time variable and set this number from 10 to 1, because now when we start up our game and the loading screen actually appears, we'll pretty much instantly see loading your data is taking longer than usual, and that's what it should look like. But of course, we're just testing it out to make sure that that's all working correctly as it should be. And of course, I'll go back inside of here and reset this back to 10 from 1. So anyways, ladies and gentlemen, with all that being said, that's going to be it for this episode. As always, if you guys did enjoy the video, make sure you smash the like button. Go check my Patreon out if you want to support me and gain access to the game file that we made during this episode. And I'll see you guys in the next episode.